The derivative of a constant. I told you, by the way, that derivative and differential is the same thing basically. Now, differential is the answer of the answer of differentiation. When that is, let me make it. Oh, sorry, let me make it very clear. When I differentiate one function, for example f of x, what I get is called the differential. Let me write it more properly. Differential, and the differential is the same thing as derivative. Okay, so differential is what you get when you differentiate a function. So the answer is called a differential. So that is why the question is always to find the differential of a function, or the question will say differentiate a function. So I think you get the idea what it is. Okay, so now let us try differentiating a constant with respect to x, or derivative of any constant, not necessarily with respect to x, any constant. What is the answer? Again, let us look at the graph. The graph should show us. So let me take a constant output value. Y is equal to 3. It's a constant. See here, y is equal to 3. 3, yeah. Now this is a constant value. The value is not changing. It is a constant value. Whatever output, if I'm taking output, if this is my input, or if this is my input, or if this is my input, the output value is the same. Output value is 3 itself, 3 itself, 3 itself. See, y is equal to 3. So output value is 3 itself. It's never going to change. So it's a constant. Now, so what is the slope of the tangent at this line? For that, we know that for a straight line, the tangent is straight line itself. So basically the tangent is like this. Now what is the slope here? What is the slope of a fully horizontal line? We know that slope is basically, rise by run, or if you are not studied, I don't know how you have studied it. The slope is basically the change in output by change in input. Now the change in output is, what is change in output? There's no change in output, so the output is 0, divided by change in input. What is the change in input? Suppose I'm taking this distance and this distance. It is 1 and okay, let me take another distance. 1 and 3. What is the distance here? The distance is 3 minus 1 and 2. 0 by 2, which is so whatever the input value doesn't even care. The output, because the numerator is 0, it is always 0. So slope is 0. Basically the slope is 0. So what do you understand from this? For a constant, you see that the slope of the tangent is always 0. So what is happening? So differential. So when you when you differentiate the function, or when you differentiate a constant, it looks like it also should be 0, and it is. So the derivative of a constant, always remember that it is always 0. Wherever whatever constant it might, if it is a constant, the derivative is 0, because it's there is no change. And by the way, always remember that calculus, the whole topic of calculus, is only applicable for changing things. That is why when our distance was changing with respect to time, we could do the differentiation. Suppose suppose the car was not moving, and the distance covered was the same, we could not do anything differential, because differential is not possible there, and there is no point of doing differentiation, because differentiation is done to find the change, or basically the differential of, when we differentiate distance by time with respect to time, we get velocity. For a car that is not moving, what is the velocity? 0, right? So you understand how this all comes together. Okay, so let me move on to something else. Now look at this derivative of sine x with respect to x. Okay, so this will be our last one, and let us look what it is. Now before we do it in the formula, again let us go back and do it in the graph. So this is the sine x function, sine x graph. So before doing this, I want to make one thing clear to you. Suppose there was a line like this. Okay, not like that, a straight line. Okay, it's not straight, but you can just imagine it to be straight. We know that the slope of a horizontal line is 0. Slope of a horizontal line is 0. So what is the slope of a vertical line? A completely vertical. Okay, it's not fully vertical. What is the slope of a fully vertical line? What is it? Again, change in y by change in x. So let me take the change in y by change in x. So if this is the change in y, it will be, okay, this is -2 -3, but anyways, so -2 minus of -3 whole divided by, what's it, anyways, what is the change in x? The x value is the same value itself, or the x value is not changing. We see that the x line, this is the x line is the same. There's no change in x. So what do we see? There's no change in, it's for the same x that you're getting all this. So the x value, the change is nothing, so it is 0, because it's a straight line, vertical line. So what do you get the slope? You get this as whatever be the numerator, numerator is -2 plus 3, which is 1, divided by 0, and anything divided by 0 is infinity. Now, so what do you understand? We can realize, or we can observe from this, that the slope of a vertical line is 0, I mean infinity. The slope of a vertical line is infinity. The slope of a horizontal line is 0, and this can be understood that, a line, this is a slope 0, and from this the slope starts increasing, slope increases, and then the highest slope is when the line is vertical. So I think you can connect all these things. Now with the knowledge of this thing, let us try to solve this. So this is the sine x graph of sine x. Now I will draw the tangents at this point, at this point, at this point, and at this point, at this point. I'm only drawing tangents at these points now for your understanding, so to give you a rough idea of what is happening. Now then I will now let me draw the tangents. So the tangent at the point 0 is like this. This is a tangent at the point 0, and the tangent at this point is like this, and the tangent at this point is again like this, and the tangent at this point is again like this. This is a repeating, sin x is repeating, it's a cycle, it's like a cycle. So that is why, remember in the trigonometry, when we studied sin x and cos x with the help of a unit circle. Get it? So this here, the tangent is again like this, straight. Forgive my drawing. So like this. Okay. Now, so the slope of a vertical line, we came to know it as infinity. Now, so what is the maximum value a trigonometric function can take? So a trigonometric function can take the maximum value 1, right? Any trigonometric function, the maximum value that you can get for sine and cos, for sine or cos, the maximum value, or any trigonometric function, I would say, the maximum value that you can get is 1. So with that, I can say that this point, the slope of this point should reach somewhere here. This should be around 1. And the slope of this point, what is the slope of a horizontal line? The slope of a horizontal line is 0. So I will draw it as 0. I'll mark the point 0 here. Okay. Now, this is again the vertical line. So the slope of this line should be infinity. But this graph is going down now. Here the graph is going up. Now this graph is going down. So the slope will be negative infinity. And so what is the negative infinity? What is the most minimum value which a trigonometric function can take? And that is -1. So here -1. So sine or cos, if you take sine or cos, the most minimum value that the function can take is -1. So I will mark -1 here. Let me take that also off, yeah, -1 here. Then here we have the slope of a horizontal line, which is again 0. Then here we have a vertical line, and we know that the graph is going up, so maximum value, which is 1. So here this will be 1. Yeah. So I have marked the points now. Now let me draw the graph. So what I will do is I will take this graph off. Okay, and don't worry, I'll bring that up again, but for some time I'll take this sin x graph off and I'll bring back what our points was, and now we will try joining the points. So let me do it with an orange line. Okay, orange color. So the graph comes from this point like this, then it goes to this minimum value, then it comes to 0, then it goes to the high value, and then it keeps on repeating here also. So this is, and if I am bringing the sin x graph, and if you look at this graph what we just drew, this is what you see. Okay, now I will take all this yellow off. I'm taking all these yellows off because yellow was only for drawing the graph, which we now drew. So I'm taking these points off. Okay, now you get a clearer view of what we actually did. Okay, now what is this? So what is this new graph? What is this new graph that we drew? And if I am, let me take the sin x, let me take the sin x off, and if I am drawing the graph of cos x, this is what I get. Now let me show you what I drew. This was what I drew, and do you see, of course my drawing was a little rough drawing, but do you see that this is the shape of this is the shape of cos x. Do you see that? So this is, so when we differentiated sine, when we took the slope of the tangents of sine, what we got was, so when we differentiated with respect to x sine, what we got was cos of x. So when you see how both of them come together, and so looking at this principle, we should get the same thing when we so let us look at how to prove derivative of sine x, or how to find the derivative of sine x with the help of the formula now. So using the formula, it is d by dx of why dx, because it's with respect to x. Okay, so d by dx of sine of x. Oh, by the way, always remember that sine x is s is written in small letters. I keep forgetting that. So okay, is equal to limit dx tends to 0, approaches 0, then sine of x plus dx, I'm changing the input a little, adding a little to the input, minus sine of sine of x itself, so the change in the output divided by change in input, that is dx. Okay, now so I have sine of a plus b here, sine of a plus b. So solving that, it is limit dx goes to 0, sine of a plus b, so sine of a, sine a cos b plus cos a sine b, so sine x cos dx and plus sine dx cos, okay, I'm changing it a little to the right because I don't have space, cos x minus sine x. Okay, phew, I adjusted that. Okay, whole divided by dx. Now I wanted to look to the question carefully, and you will see that there's a sine x here and there's a sine x here. So I'm taking these things common, and when I take it common, what happens? Limit dx tends to 0. I'm taking minus sine x common, okay? I'm taking minus sine x common. So minus sine x. So if it is minus sine x, the inside will be minus cos dx. Minus cos dx. And here it is minus sine x itself, so plus 1. Because why it's plus 1? Because I took minus sine dx common. So minus sine dx, so into minus cos dx, that is sine x cos dx, plus 1, that will be minus sine x. Okay. Now this plus this thing, so plus sine dx cos x. Okay, cos x and the whole divided by dx. Okay, don't forget to put the brackets. Now we are going to split the limits, so it will be limit dx goes to 0, and it will be minus sine x of 1 minus cos dx. I mean minus cos dx plus 1, I'm writing as 1 minus cos dx, I'm rearranging the term, whole divided by dx. Okay, this plus limit okay, this plus limit dx goes to 0, this term, so it will be sin dx cos x whole divided by dx. Okay, now this is where you need to look carefully. We have 1 minus cos dx divided by dx. So in the last video of limits, you learned, right? I mean, I had showed you that limit x tends to 0, 1 minus cos x divided by x approaches 1, right? I mean, approaches 0, I'm sorry. So limit x tends to 0, 1 minus cos x by x approaches 0. So here also it is 1 minus cos dx by dx, the same thing. So, and dx is approaching 0. So therefore, this value approaches 0. Fine. Now 0 into anything is 0. So this whole thing becomes 0. So I'm taking that off now. Okay. Now what we are left is with this thing. Now when you look at this, what we can do? Here too we see one thing, that is we see sin dx by dx, and dx is approaching 0. So when x tends to 0, sin x by x approaches 1, right? We saw that in the video. So we see that this much value approaches 1. So this is equal to limit. I mean, we can change the limit now because limit is going, there is no more dx. So we can write that since this whole value approaches 1, it is 1 into cos x, which is cos x. So what is our answer? Differential or the derivative of sin x is cos x. So that, ends our discussion about differentiation. I know this is a pretty long video, but I think these many examples and was necessary for you guys to understand how to solve this thing. At the same time, I wanted to show you the graph, what is happening, so that you can understand that differentiation is not just a substitution of something in some formula. So it is not a formula. It is an idea of making things go smaller and smaller, and then trying to find the output, and then trying to find the change of the output with respect to that small change in the input. So that is what we are trying to do. So because I wanted you guys to understand that is why I showed you in the graph. Okay, so anyways, enough of me talking. So then, okay guys, bye bye.